All right. Well, one tribute, one thing that actually signifies or exemplifies our rationality is our ability. I am just deciding on another color just to keep it interesting here. Is the idea of problem solving, and we engage in problem solving every day in terms of whether it's the words we choose to speak, like I'm doing right now, or whether it's how do I get through a particular traffic. Some of you might be taking your midterm right now, and you're doing a fair amount of problem solving. But one of the first ways that we really learn or solve a problem is, and it's the most basic actually, is trial and error. If you remember back when we were talking about learning and so forth, and Edward Thorndike and his puzzle boxes for cats, this was the primary method. Essentially, they tried something, it didn't work, and then they kept trying something until it did work, and then they do that over and over again. So trial and error is really the most basic one where we tend to start. For other problems, we engage in something called an algorithm. And algorithms are essentially, we look at the problem and we create, in a sense, a step-by-step approach to solve the problem. So in a lot of ways, we do them on a regular basis, and once we get the algorithm down, essentially we use it over and over again. And one of the things that computers actually use is the same idea. So you give it a task. For example, let me give you an example. If you've ever used Excel, they have built-in functions, for example, to estimate or to calculate an average, let's say. This is an algorithm. It basically picks out the number of cells that you determine, adds it up, divides the number of cells, and that's an algorithm. It's a way to solve a problem. And the thing is that essentially the more complex the problem gets, the more laborious, more complex, more laborious it becomes, because essentially if we were to, as your book has it in your book, they have this SPLOYOCHYG. Now, if you take your first algorithmic attempt and divide it up into chunks, like say let's take the first letters that I look at and say, well, can I do these? Can I do these into chunks and say, well, no, that doesn't render much. I can go from loy. I can go with the most recognizable characteristics here, but that doesn't do it. And algorithms, the more complex the problem is, the more difficult and inefficient it becomes. So essentially, with a word like this that isn't determined just yet, you have over 900,000, I'll just say K, over 900,000 permutations of this problem. So if you keep changing letters in each position and keep moving them around in that position, you have 900,000 tries before you might actually begin to figure out exactly what it is. And so algorithms are good. They usually trial and error and algorithms are probably the first attempts at solving a problem, but they, because they tend to be so inefficient in terms of time, we tend to abandon it entirely at some point in time. And then we step back, and that's what our next topic is when we start talking about problem solving. So the next part of problem solving is we already talked about trial and error. We talked about algorithms and how they play a reasonable part. But one of the things that is often remarkable about our problem-solving ability is something that we refer to as insight. And how insight is actually developed is really quite fascinating, because we arrive at a conclusion without going through all of those inane steps that are part of an algorithm. So essentially, when we talk about insight, it is basically an abrupt and what appears to be a true solution or a satisfying solution to whatever a particular problem is. And it doesn't take into account all the necessary other steps that an algorithm does. So sometimes if we step back from that word and look at it and begin to do in our own mind, suddenly we have this flash of insight, and essentially I have solved the problem. What's interesting is that even in brain physiology and brain chemistry, when we solve a problem, what we basically see is we see a lot of activity up here in the frontal lobe, where all the problem-solving executive functions occur. And then we have this thing called the aha moment, where the solution comes to us, and there is this instantaneous almost reaction right here. Let me pull out a different pen here so you can see where I'm pointing to. But right here in this area in the temporal lobe, you see this flash of activity when the aha moment actually occurs. Before that, nothing is going on, or at least it doesn't look like a whole lot is going on. And then you have this incredible burst of activity that results in what you see in here. Insight itself tends to strike suddenly. And one of the people that was instrumental in studying this was a ape researcher who basically gave apes a variety of problems to solve, and they would look at it and look at it. They would try it, and in the ape study, basically, if I were to draw the room, what you had was a room like this with assorted boxes on the floor of different sizes. And here you'd have basically a banana hanging, and the ape had to figure out a way to get to this and get the banana down. They also had a stick laying around on the floor, and he would try the different combinations of boxes and still not be able to. The ceiling was high enough that he wasn't able to reach it by hand just by piling the boxes up. So essentially, it would come to a point where he'd just leave the boxes scattered, and he'd go over to this corner and survey what the problem was, and suddenly come to a solution, put the boxes on top of each other, take the stick, and knock the banana off with the stick. And that was a good example of insight, even in apes, where instantaneously something tends to occur. Now, there's a downside to this, because our cognitive tendencies tend to get us stuck at times. And so we will seek out a particular solution. And let's just say that I think, well, looking at that word, I've already figured out what the word is. and then somebody basically says, it's not the word that you think it is, and provides us with the evidence to prove it. And essentially, one of the key things to keep in mind is something we refer to as confirmation bias. So essentially, once we have formed our opinion about a particular issue, about a particular problem, we find it very difficult to get outside of the data. So we end up taking data only that confirms what we're thinking. And we don't take into account data that disconfirms it. And so a confirmation bias is a key term that gets in our way, essentially, and doesn't allow us to be flexible with the facts that we actually have. One of the quotes, essentially, in your book, which is interesting, is ordinary people evade facts, become inconsistent, or systematically defend themselves against the threat of new information relevant to the issue. And that generally is the case, and it's because of this confirmation bias that this tends to occur. Now, another concept to add in here that is also equally as important is called a mental set, or a psychological set. And essentially what that means, it builds on the confirmation bias, but it is our tendency to approach a problem with a mindset of what has worked for us before. And so a good example is the matchstick problem that is in your book, and how do we create, in a sense, a triangle, equilateral triangle, to create 4 equilateral triangles, I should say. And another good example is showing somebody a box of matches, a candle, and a thumbtack, and say, what can you build with this? Or how would you build something that would provide light for a room? And because how set we are in looking at, you only use a matchbox as a matchbox, that's a mental set, without realizing that I can take the matchbox out, empty all the matches out of it, use the thumbtack to push the matchbox into a wall and sit the candle in the matchbox, and then I have basically a little candelabra out of it all. So mental set is a huge concept that is quite important in psychology, and we see it happening all the time. Even in this season of politics, you have a good example of confirmation bias and mental set about how people feel about each candidate. Now, let's turn our attention to making good and bad decisions.